Okay, so let's go ahead and narrow to today in terms of what the lesson is going to be tomorrow. So we're doing 7GA 1, solving problems, essentially scale factor. So let's talk a little bit about your know and show. This time we're going to do it a little bit differently. We're going to start with the show. What do they need to be able to show at the end of the lesson? And then we'll go back to, okay, in order to be able to show it, what do they need to know? This was just introduced to me. And so I thought, oh, it's backwards design, right? It's not very difficult.
So they should be able to show that they can draw an appropriate diagram for a scale drawing. They should be able to show like that they can put those values into a table, and especially like they're identifying the right corresponding sides, because that'll be the big step to the table. They will have to be able to show that they know how to use the scale factor, so they might be able to like get
the formula
table.
Specifically?
Yeah, like finding the missing values.
Yes.
So once they identify that, are they going to be able to put in the blank values in the table?
So is that not using the scale factor formula?
I mean, they don't have to write an equation, but so it might just be for them more like multiplication that's happening in their head.
Okay. Should they be able to? Do they need to be able to use a scale factor formula in order to be able to do this and or check work? Because I had scale factor formula.
Okay.
But I mean, we can spar. Let's talk.
I've had them use the equation, like the y equals k times x equation for regular scale factor, not scale factor, regular proportional relationships. So they should be able to use it.
And then in the exit ticket, was there not? Where's the other exit ticket? Now I used it to check my work.
Okay.
So, I mean, I would say if you don't, I would say based on the fact that we're coming back to this standard again, that I think it's actually necessary for them to be able to understand that.
Okay.
Because when they go to do the charting, and you have the chart, I said chart with proper XY placement, just because in one of the examples they didn't do like the order of the sides that I would have done. They did like a different order. So just making sure that they are putting things in the proper, the X is in the X column and then the Y is in the Y column. So that was just like a little bit more specific than what you had. I also had appropriately sized diagrams. I think you had, what did you say about diagrams?
I think I just said accurate diagram. Or appropriate.
Yeah. Okay. And I just added size to that. And then you had one more, graphing.
Yeah, and then I wrote it down here. Oh yes. Show that they can identify an actual point on the graph. Not a fake point or a half point.
You mean when you say that, do you mean like specific, like how when we were doing the line the number lines, they were like putting numbers in? Is that what you mean? Like they would put, like it would be the 4 tick would be here, but the 4 would be way over here, or their dot, they wouldn't stop directly at the 4 or the 2 or whatever the number was.
Yeah.
Is that what you mean when you say that?
I mostly mean, so like a lot of times with the graphs, like you see this point right here. I can see them choosing this as a point, even though it's not really
I understand
on the
what you're
corner.
saying.
We've been practicing a lot. Like it needs to be on the intersection of the grid line in order for you to like know what the X and Y is. Otherwise, you are estimating.
Okay, so I'm gonna repeat the show. We can put a question mark next to scale factor formula. I would use it to check. You may not chart with proper XY placement, appropriately sized diagram, and then graphing appropriate points. So what do they need to be able to know in order to be able to show that?
Okay, so they will have to know what corresponding means.
Yep, that's one of my vocab words.
What that means. And then obviously, like, I mean, some of it is, even if they can kind of repeat back to me what corresponding means, like it means it's in the same place, they still will have trouble actually following that pattern. So
similar to what I was saying about the chart and the
it's
XY
like
placement.
a visual thing for them. Like there is a bit of learning that has to happen where they can actually, like, I don't know, like visualize, yes, these are the same side because they're on the same.
Yeah.
So knowing,
so we have understanding what corresponding is. What else do you have? You had how scale factor is used, applying to sides, lengths, not area.
Also know that the scale factor, like it can be an enlargement or a reduction. It might just be the reciprocal.
That's actually a good one, because in all of the videos I watched, they show both, and then a few of the triangles are that as well.
Yeah. And that was another reason. I'm not sure with the equation sometimes, just because unlike the regular proportional relationships with scale factor, it is kind of like I can just look and see, like whatever number I got, if it got bigger, it should be in one
larger.
way. If it's smaller, it should be in one way.
Yeah.
And I have the key question for at the end of their like practice.
Okay.
And I specifically have it. It's this like, it's just a scenario.
Got it.
But I specifically, like, there's no images for them to look at, so they have to just read it and try and interpret what's happening. So that's going to be kind of where a big productive struggle spot for them, I'm hoping.
Got it. Okay. Anything else? So how scale factor is used, that how it impacts area. So the specifics of scale factor, the difference between area and perimeter. Why did you say that for this one? You think they are trying to add?
So the DNA
add for perimeter
question, some of them in the bank and in the curriculum, it does ask them about area as well.
Got it.
And on the module assessment, there was a question that they all totally bombed, where it was, essentially the area does not get multiplied by the scale factor. It gets multiplied by the scale factor squared.
Got it.
So they have to understand.
But do they need that for today? For today's lesson?
Well, they do need to know that area is not perimeter for that DNA question, because it asks them what is the perimeter of
what
Lee's
DNA
room.
question?
The one in the notes. Yeah, this question.
Got it.
And it asks about perimeter.
Oh, I understand. You pulled this straight out of DNA.
Yeah.
Got it.
Yeah, that was the question that they
got it.
They were 44% got that correct.
Got it.
Was the lowest.
Okay. And then the last thing I have for no is that scale factor is the same exact dimensions but different size. Because I don't know that they realize that.
Yeah.
And so there may be, and this is a side note, but there may be a few videos or a few different ways that you show them that are not only triangular. I saw a video with like dogs with happy faces, and it just made them think about like the dimensions and whether or not it was a scale copy, similar to this one. But I think seeing it multiple times, multiple ways, I think could potentially be helpful.
Yeah.
But no worries there. Okay, so let's get into where they are going to have a gap in understanding. So you identified the areas of productive struggle, specifically the same question, which is exactly what I thought, because there are so many and they're all triangles, and our kids and their familiarity with this they've not had as much experience with these, and so you're going to assign them. However, is that accurate?
Yes.
So everybody won't get the same set of triangles.
No.
Will everybody get one that is a scaled?
Yes.
Okay.
Yeah. I was planning on kind of like, students that are in maybe my lower group right now, I'm going to give them, just looking at this one, and then maybe like this one. And then, I'm going to give these ones with fractions maybe to the higher level groups.
Got it. Okay. So let's name the productive struggle. What is it going to be?
It's going to be, they're going to want to look at it and tell if it's proportional. And they're going to have to actually calculate each side.
So that's going to be the productive struggle, the actual calculation. Mm-hmm. Okay. And then independent key question. You said purposefully. The one we just referenced.
Yeah.
And let's go ahead and read that for the reference of. Go ahead and read that independent question.
It says, Anaya is comparing the side lengths of two figures. She notices that the original figure has a width of 8 centimeters and the scale drawing has a width of 4 centimeters. So she decides that the scale factor is 2. Explain why you agree or disagree with her 1 to 2 full sentences.
Okay. At that point, they're going to do that independently, but they're going to debrief this question, I'm assuming.
Yeah.
Okay. So how are they going to debrief this? Is this where our turn and talk is going to happen?
Yeah.
Okay. This part is important. And so I want to make sure that you have, when you're going around and you're listening or kids are kind of sharing out, that you are making sure that they are, that you have your exemplar out, your expected response, and you're highlighting what they need to be saying. Mm-hmm. Or what you're listening for. You're going through, and when you're doing your academic monitoring of that particular piece, you're listening for certain language. Mm-hmm. So we have question 3 is going to be the question of, this task 3, and then this activity 2 rather, and then you said question 3. Is this what you meant by question 3, or you meant this part? I was clarifying.
I guess I was looking at this.
I
kind of meant the whole thing.
Got it. Okay, so we know they're going to struggle being able to identify which ones are scale copies, but not only visually, but also doing the calculations. Mm-hmm. Okay.